back in 6.2, we're talking about multiplying and dividing radical expressions. And when we are simplifying these radical expressions, and I look at this example, the cubed root of 128x to the 7th. Now, to simplify this, we just want to make sure that there are no perfect cube factors within this when we're done. So we can go ahead and break it down. Let's use our radical properties and just break these things out. Let's expand this out to where we can look at it. Okay, so now that I have sort of expanded this out, I have the cubed root of 64 times 2 times x cubed times x cubed times x to the first. So there we have our x to the 7th. We also have 64 times 2, which is 128. So I know that this is the cubed root. So I know that 64 is 4 to the 3rd, or the cubed root, or 4 cubed. And then I go ahead and just rewrite this. And I can simplify this now, and I can bring out the cubed root here. The cubed root of something cubed is going to be 4. So 4, cubed root of 4 cubed is 4. Then I know here that this is going to bring 1 out, bring 2 of my x's out, and that leaves behind in my cubed root 2x. So I was able to, in this simplifying this cubed root, I brought out all my perfect cubes. Okay, so now when simplifying with a product like we did today in class, what is the simplest form of the square root of 45x to the 5th y to the 3rd times the square root of 35x y to the 4th? And what I want to do in simplifying a product is I just want to go ahead and multiply the two radicands together, and then we are going to look for perfect squares. So first we're going to go ahead and multiply it together. Okay, so as we simplify this product, write everything out, you can see here that we I just went ahead and just showed you I'm multiplying everything together, and when I do it, I know that I'm looking for the square root. So what I've done is I've sort of split everything up into my perfect squares. So I know here that the square root of 9 is going to be 3. The square root of 25 is going to be 5. Then the square root thereof x cubed times x cubed is going to be x cubed, and then the same thing for my y cubed, and that leaves behind a square root of 7y, and of course I didn't finish simplifying that. That should be 15x to the 3rd y to the 3rd, and leaving the square root of 7y behind. Okay, as we go through and we continue with these radical expressions, we talk about dividing radical expressions. So what I can do is I can go ahead and I can break this up, and I'm going to expand it out because I'm actually going to be able to get rid of some stuff. But I do know the big thing here, when I'm dividing radical expressions, I want to rationalize the denominator. And that means that I want to make sure that there are no radicals in this situation. There are no radicals in the denominator, so we're going to work to get rid of that. And I'm going to go ahead, expand it out, and see where my factors lead me. So as I've expanded this out, I've done some simplifying, and I know that 50 is going to be the square root of 25 times 2 times 6x, and then that's going to be all over what I've done is that's going to be all over the square root of 2x to the 4th. And as I expand these out more into my perfect squares, if you notice here we have square root of 2 over square root of 2, and we know that that can be canceled out, or that becomes 1, and the square root of x to the 4th over the square root of x to the 4th also cancels out and becomes the value of 1. So we have, using the multiplication property of 1, we've been able to simplify our expression. And now if we just look and see what's left, what's the square root of 25? And we know the square root of 25 is 5, and the square root of x squared is just simply going to be x. So there you have it. We have a solution, a simplified radical using division. And this final one, rationalizing the denominator, let's see, we will work on this now. In order to simplify this denominator, the easiest thing for us to do is create perfect cubes in the denominator. And in doing so, let's see, what are we going to multiply by? Well, in order to get a perfect cube of 5, what I can do is I can multiply by 25, because we know 5 times 5 times 5 is 5 times 25, or 125. And to find that perfect cube of y, I can take those two y's and multiply another y to it, and I get the cubed root of 25y to the first. And multiplying by the value of 1, I know that if I multiply the top by it, I must multiply the bottom by it. Now when I multiply these things out, I'm going to get, let's see, 1 second. And then finally, when we've simplified this out, of course, we had to rationalize the denominator, but we multiply everything out. And we have the cubed root of 175xy over the cubed root of 5 cubed and y cubed. So I'm able to simplify these radicals here, the denominator, and I have the cubed root of 175xy over 5y. And with that, what we have, so as a quick review, we did the radical multiplying and dividing radical expressions today, and I showed you the simplest form, how to simplify a cubed root here. And let's see, simplifying a cubed root, and we turned around and we simplified a product by multiplying it here. We multiplied it and then simplified it based on the requirements. Then the simplest form, what we did was we used division, multiplication property of 1 to eliminate some excess stuff. And then finally, rationalizing the denominator, we multiplied the denominator by what we needed to create, in this case, perfect cubes to counteract the cube root. And then there is your answer in your work there. And that recaps this section from class today.